Welcome back to the AI in Civil Engineering course. In the last episode, I did an introduction of what you expect to see in this course and how we are going to achieve it. So now in this episode, we are just going to start with the technical part, which is the actual project, but we will start from the bottom and then we go to the top. So the first thing we need to do is to download the data set. I will click on this link. I will also attach this link in the description so that you can see for yourself. If I click on this link, it will take you to Kaggle, where you can simply just read about the data set and then you download it. So click on download and then you have the data set. I have this data already, so I will not need to download. Sometimes you might be required to register if you've not registered before, or maybe just sign in if you have been able to register before. All right, I will close this, and when you download the data, I advise that you place the data in the same path as where you have your Jupyter notebook. This is not compulsory, but it's quite easy that way because you don't need to look for where the data is, that kind of thing. So it's much more easier that way. As you know, we are trying to predict the strength of concrete. Okay. And then right now, as I told you, we have three core concepts. The first one is the data engineering. The second one is the machine learning. And the third part is the deep learning. So we are in the aspect of the data engineering. The data engineering, I decided to split it into three phases. So the phase one is simply called the data cleaning. The second phase is called the exploratory data analysis. And the third phase is called feature engineering. In this episode, we will just be working on data cleaning. And what data cleaning encompasses is structure check, missing values, duplicates, and then we will diagnose for the outliers. So these are the four aspects that you should expect to see in this episode. So that being said, let's just dive into it. The first step we need to do in all aspects is to import the libraries that we require. So I will import pandas and I will give it an alias, which is PD. This is the common alias that people give to it. Pandas is for data manipulation, for creating data frame and for just manipulating your data. So it's very essential. I will also import NumPy. If we have to do any mathematics, we might not need it, but maybe. Then I will import matplotlib dot pyplots, and I will give it an alias as well, which is PLT. This is for data visualization. I will import Seaborn as SNS. This is also for data visualization. And then for now, let's just let's do it step by step. We should just import what we need. I think these are all what we need for the data cleaning. I also like to set the style for my Seaborn to white grid. So I will just say SNS dot style. SNS dot set. So I'm going to set, then I will do style equals to white grid. And if everything is fine, if you click on run, this should run perfectly. Okay, so now this has run. The next thing we need to do now is to load our data. We should load it into a data frame. So if you check the data is saved as concrete data.csv. If the data is not saved as this, you should know what it is saved as. I think I probably have changed the name, I don't remember, but make sure you know what the data is saved as, the name of the data, okay? Because that is necessary for you to load the data. I will call this data frame, I will assign it to an object called df, and df, I will load it with pandas, which is pd.read CSV. The data is a CSV file, and then the name. As you saw, the name is concrete data.csv. So now I have loaded the data frame into the df object. I need to view the first 5 rows in the data frame. So by doing that, I will say df.add. Now I have a glimpse, like a preview of what the data looks like. So these are the first row in the data. If you see, the first column corresponds to cement, the second column corresponds to blast furnace slag, the third fly ash, we have water, super plasticizer, coarse aggregate, fine aggregate, and the age at which this strength is being measured. So we have the strength. So in total, we have 9 columns. Now, each observation, the horizontal row is called observation. So each observation corresponds to 1 meter cube of concrete. So what these data are telling you is that for this particular sample of concrete, this is one sample, right? It's an observation. For this one sample of concrete, one sample of 1 meter cube of concrete, they have used 540 kilogram of cement. Maybe a bag of cement is 50 kg. So you will know the number by saying 540 divided by 50. You will know the number of cement that is used in 1 meter cube. They have used no blast furnace. They did not use fly ash. They used 162 kilogram of water. They used 2.5 kilogram of super plasticizer. They used 1,040 kilogram of coarse aggregate. They used 676 kilogram of fine aggregate. And then after 28 days, they measured the strength, and the strength was 79.99 Newton per millimeter squared. So this is one observation, and then they go on until the last data. So I believe you understand the data right now. So the next thing we need to do now is to peep further into the data and see, for example, I can see now that we have 9 columns, but I don't know how many observations we have. To simply know how many observations we have, we can use a function, not a function actually, it's an attribute. We can use an attribute called shape. It's also from the pandas. So I will say df.shape. Don't forget that the data frame is already an object of this pandas stuff. So if I do df.shape and I run this will give me this in form of a tuple. I have 1,030 observations, which corresponds to 1,030 rows. And then I have 9 columns. It is easy for me to know the number of columns. 1, 2, 3, 4, 5, 6, 7, 8, 9. Quite easy. But for the rows, I have to, so it's not easy to display all of them. You can simply just check df.shape and know how many observations you have. The next thing we will be interested in seeing is to know if at any point in time we have a missing value. Not necessarily a missing value, a missing value. So sometimes you might see NaN in your data. It means the data was not filled, so it is empty. And when you have such empty data, you cannot just put that into your model. So you need to be certain that you don't have any zero value like that. So in order to do that, I can just say df.isNull. If I run this as it is, it will give me a Boolean response, which means it will just tell me that false, 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 true, false, true. But in this case, I'm not interested in seeing this. I just want to know how many null values we have. So I'm going to sum them up. I'll do .sum, and then it gives me the number. It tells me that for this column, I have 0 null values. As you can see, in all of them, there is no null values. This tells me that all of this data has an input in every cell. So this is very nice, because if we have a null value, we will have 2 options. It's either we drop that observation or we try to fill in the data of the observation. And to do that, there are different methods. We are not going to do that, but in this case, we don't even have, so we don't need to worry about that. So the next thing we will try to do is to see the data types, because the data type is very essential. As you would see, these are like floats. Maybe sometimes we have integer. This is an integer, right? Maybe this is supposed to be float or integer. What if this happens to be an object? Then it will become a problem. So we need to know if this is seen as a float or if it is seen as an object. We need to be certain that the that the data type is correct. Okay, so to do that, I would do df. I probably should not be cleaning what I have done, so I will type it back. Okay, then the next one is I'll just do df dot types. So this will tell me the data frame. You see, for cement, it is float. As you can see, float is decimal. When there is decimal, like a decimal place, you see that is float. And then fly ash, it's also float. This is float. This is float. This is float. This is also float. This is float. And this is integer. As you can see, it is integer. And then this is float as well. So all of these are correct based on what we expect. So, but if this is an object, for example, then you will need to change this from object to float. All right, so this is very important. And then the next thing we need to do is that, okay, you would see that I had to do 3 steps in order to get this information. But in some cases, you don't need to do df.shape is null, df.types, all of that. You can simply just do df.info. When you do df.info, all of these 3 datas, all of these 3 information that you need, you will get it from just this df.info. So if I click this, you would see that the number of columns is here, 9. The number of observations is there as well, 1030. Also, you can see the null values. It tells me that I have 1030 non-null values. So I have 1030 observation and 1030 non-null values. So that simply means 0 null values, right? So you will get that information of null. And then also the data type is also attached here. So all of that information that we try to find from df.shape, from this, you can simply get it from df.info. So maybe sometimes you just don't use all of this and use this, except maybe in some cases when you're just peculiar about some particular thing. Then we move to the next step. Now, in this step now, we need to understand the statistical summary of our data frame. We need to know how it is being dispersed and all of that. So I will use df.describe. So this will describe my data statistically. If I run this, it tells me that for cement, of course, the number of count will be 1030 because that's the number of observation. All of this will be the same. All of this will be the same. Then the mean is 281, the standard deviation 104, the minimum value 102, the 25 percentile, the 50 percentile, which is the same thing as the median, the 75 percentile, and the maximum value is 540. So there is no, if you see here that the data here, the kilogram of the cement used here is 540, it's telling you that in all of this column, the maximum kilogram that is used in 1 meter cube of concrete is 540 kilogram, because we have confirmed that from here. It tells me that the maximum value that I will see in that column is 540 kilogram. And the minimum value that I will see is 102 kilogram. This is like 2 bags of cement, because 1 bag of cement corresponds to about 50 kilogram. So if I have 102 kilogram, it's like 2 bags of cement. So, and the median is 272. That's like 5 bags of cement, right? Okay, we have the same summary for the blast furnace. We have the same summary for water, for all of this, okay? So that's quite nice. Then the next step now will be to see if we have any duplicate value in our data frame. Because if we have a duplicate value, it means we have one data point, like one observation that is repeated more than 1 time. We don't want an observation to be repeated more than 1 time, because if you repeat it more than 1 time, you are basically telling something to the model more than 1 time. So that will affect the way it thinks. It's like when you are teaching a child something, you tell him one thing 10 times, and then you tell him another thing 1 time. The child will most likely remember what you told him 10 times than what you told him 1 time. So it's the same thing if you have a duplicate value, a duplicate observation in your data. The model will remember the ones you duplicate because there are more data points of it. Okay, so you need to be certain that every observation is only appended in the model 1 time. So how do we do that? I can simply just say df.duplicated. If I run this, it's going to give me a boolean So it gave me a true, false, true, false, true, false, which is not what I need. So once again, I will do .sum. And then it tells me that in these 1030 observations that I have, there are actually 25 duplicates. So what do I do then? I need to drop it. Simple, right? So I will say df.drop duplicates. In this case, not duplicated, it is duplicates. So I will drop this, and then I will assign this to an object called df. This is very important because if you don't assign it, it's just going to be an instantaneous, as if you're just viewing the data. It's not going to put it in place. So another thing you could do if you don't want to assign it to df is you can say in place equals to true. You can try this as well, but I prefer to assign it to the object. So if I do this now, I will drop all of those 25 duplicates. Now you need to be certain that it has been dropped. So to do that, you can just simply check the shape. So I will do df.shape. If you remember, we have 1030 observations, right? So now that I've dropped 25, I should be expecting to see 1005. So if I run this, you would see this has reduced by 25. So it's now 1005. So this is nice. However, after I have dropped 25 observations, you realize that the index will have been, it will become misarranged. This is what index means. Index is just the numbering 0, 1, 2, 3, 4. So say, for example, this observation, first observation and the second observation, they are the same. And I have dropped this because it's a duplicate. Now, I have dropped the second one. Let's say, for example, now this index will now become 0, 2, 3, 4. It will not be arranged properly. 0, 1, 2, 3, 4. Okay, so in order to do that, I need to reset my index. Let's see, for example, if I do df.tail, maybe we might be lucky to see 25, 26, 27, 20, 29. Okay, it doesn't work like that. So I'm just going to, let's see, df. I don't think it's in add. So I will just simply reset. So I will say df.reset index and then drop equals to true. Then I run this. Then the next step will be to visualize if we have any outliers in our data frame.